Assalamualaikum warahmatullahi wabarakatuh. And hi, my name is Muhammad Iskandar bin NAZIRI, CE18105. I am the group from the A2. Now, today I would like to present about this experiment, which is a digital communication system, FDMA versus or FDMA. So I will present the question one. It's about the demonstration and Hamming channel coding technique using MATLAB for the message length of the 3 bits. So and through to the MATLAB. Okay. So this is a coding for demonstrate Hamming channel coding. So this question is about the when happened that when we inform when give send the information from the transmitter to the receiver in the situation of the raining or not. So we start for the situation of the without no without raining. So first step is about the we explain the coding. Okay, I will step by step. Okay, first up is about the CLN and clear. Clear is for the clear or the result from the command window. And then we go to the m equal to 3 is the length 3 bits. And n is equal to 2 the power of m minus 1. And k is n minus m. So next up is about the situation of the without raining. It's not raining. And given the message, this is a message information that they given from the doctor in the class last week. So this is our information. So next up is about humming channel code. This stuff is about the when situation is not raining. So what happened that the humming will be sensed the when if the information given the error will be correction of the information when they to receive. So the situation now is about this part is a situation of the without raining. So if that I run the information, so the stand the result on the computer. So this is a result for information when the when Hamming channel code is a situation is not the raining, there will be pop up the result. So this is a Hamming channel code. So when we want to receive, we go to the decode coding, and then we get the same result from the from transmitter. So means that when we transmit the default information, and then we when through in the space we transmit the Hamming coding the Hamming without having any disturbance or noise, which means that when you without running the information is still in the constant without any error. And then when you try to receive the information of the sending is the same as for the transmitter send. So this is the result for the information, same information. That what if that when the raining happen, what happen raining in the broadcasting when it broadcasts. So I mean that, so what if what happened and the situation the when we give information when the give information in the raining situation. So how every next step is about this is okay, this section is about the raining situation. Okay, next. Okay, this hash code for the without raining, rainy situation. This hash code for the when the rainy situation is already. So that I just change the information because that when the raining, the raining the distribution will be come to noise the information. So information will be changed the Hamming code. So I changed the Hamming code from the real information. Then and then the function of a Hamming channel code is for to correctional the error. So after that, when the correctional error, and then will be come out the result the same as the from the estimation. So means that the function of the Hamming channel code is for correctional when the situation of the distribution. So means that if we want to message the want to send the information in the rainy situation, the Hamming code will be back up to sense the information is correctional with the correctional to correct the error. To correct the error the code of the Hamming channel code, and then to be sent to the receiver. the same as result from the transmitters are giving. So that's for the question one.
Assalamualaikum Doktor. Nama saya Haikal dan saya akan membentangkan untuk soalan 2. Dan untuk soalan 2 ni arahan minta untuk saya buat FDMA, SK simulation untuk hari biasa dan hari hujan. Okay, apa yang saya buat adalah saya membuat bezakan parity bit di mana untuk kali ni parity bit saya terbagi pada 2 iaitu 2 dan 4. Jadi untuk yang data ini adalah untuk parity bit 2 dan saya buat frekuensi dia adalah 0.5 dan 5. Di mana untuk hari hujan lah, untuk frekuensi dia berbeza. Jadi saya akan tunjukkan pembentangannya. So beza dekat sini adalah 0.5, yang belah kiri adalah 0.5 dan belah kanan adalah 5 frekuensi. So di sini kita tengok kadar hujan di frekuensi yang 5 adalah lebih lebat lah berbanding yang 0.5. Okay, next kita akan pergi kepada next kita akan pergi kepada kepada untuk Hamming code. Datanya di-encode daripada 3 bit channel. So daripada data ni kita dapat 111111000000. Dan untuk bila kena hujan kita boleh dapat pastikan yang untuk 0.5 still boleh baca, dan untuk hujan yang lebat kita tak dapat nak baca lah, susah nak baca. Jadi seterusnya kita tengok pada eye diagram di mana 0.5 adalah belah kiri, dua grup ni adalah belah kiri dan dua grup ni adalah belakang untuk 5 frekuensi. So kita boleh tengok kat sini kadar hujan lebat ataupun tidak lebat, frekuensi low ataupun kuat, noise kuat ataupun tidak adalah sama saja. Cumanya untuk hari biasa kita tengok dia boleh pantul dengan baik. Pantul baik, dan saya letak 0.5 dekat sini and then 5 untuk sini, still dua-dua ni susah nak baca due to noise lah. Okay, jadi seterusnya kita akan pergi pada scatter plot. Dua grup ni adalah 0.5 dan dua grup belakangan ni adalah 5 frekuensinya. Jadi di sini kita dapat kena pastilah kalau untuk data untuk hari biasa jaraknya jauh dan 01 di mana tak ada data yang tak ada noise lah, tak ada sangat baiklah, biasalah. So untuk scatter plot ni kita tengok dia punya data ni sangat ada yang rapat dan ada yang jauh. Maksudnya dari segi penjarakan tu adalah menunjukkan noise dia kurang ataupun tidak lah. Kat sini kita boleh tengok noise dia kurang tapi still ada noise lah. Kat sini pula ada noise dia tinggi tapi dia duduk dalam sekatan yang sama, dua-dua yang sama. Jadi untuk saya ubah di mana parity bit adalah 4, yang tadi 2. So nanti ini untuk 4 lah. So 4 di sini kita tengok dia datanya berbeza. So based on 0.5 punya frekuensi, hujan lebat ataupun tidak. 0.5 tak lebat, 5 lebat. Ni frekuensinya. So di sini kita tengoklah kalau kita letak 5 dia memang nampak noise dia memang tinggi lah. Okay, untuk Hamming code datanya adalah 001110001100. So bila kita letak noisekan kepadanya hujan lebat, hujan rimis, kita assume ni hujan rimis, still boleh baca lah. And then untuk yang kita letak pada 5 frekuensi pula susah sikit nak baca lah. So untuk eye diagram pula, belah kiri adalah 0.5, belah kanan adalah untuk 5. So untuk 0.5 dan 5 ni bila kita letak noise memang dua-dua ni sukarlah nak baca sebabkan noise, even ada noise sikit ataupun banyak. Jadi seterusnya akhirnya adalah scatter plot di mana belah kiri adalah 0.5 dan belah kanan adalah 5. Kita boleh tengok kat sini scatter plotnya lebih kurang juga di mana untuk low noise dan high noise lah. So itu saja daripada saya. Terima kasih.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Irfan, and for my part, I will present about question 3 for lab Mkd 2. So this is the coding for simulation on OFDMA ASK signal, which is there are two types, deferral and rainy day. So for our data is 11000011 for group A2. So the parity that I use is equal to 3, and the frequency used is 0.5. So then I will run the coding. Okay, so this is the scatter plot. This is the eye diagram, FFT signal, and this is the noisy OFDM signal. So as we can see that the amplitude during the rainy day is higher than during the normal day, which is normal day is the maximum amplitude is 1 and -1 for OFDM, or for rainy day it's more than 1, which is around yeah 1.4, 1.5. Okay, for the FT signal every bit, it can be seen that the difference is during rainy day. This is normal and rainy day. The 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 noise is more scatter and higher than normal day. So, and this is the eye diagram for normal day, and this eye diagram for rainy day, which is a lot more scatter. And normal day is just two scatter plot, 2 point of scatter plot, which is 0 and 1. And during rainy day, they have a lot of scatter plot because there's a lot of scatter plot because the unstable signal. Okay, so for this question, I've made with two comparison, which is the second one. I will change the frequency to 10. The first one I use 0.5, but still the same parity, 3. Okay, so this is the result for frequency noise during rainy day. So we can see that during normal day it's just the same as before when the frequency is 0.5, but during the rainy day the noise is a lot higher, which is more than 10. This is one, it's more than 10. And for FFT signal also it's a lot higher and a lot unstable. And for eye diagram, during normal day it's just the same as 0.5 frequency, and during rainy day a lot more scattered than before. And for scatter plot, the scatter plot is just 2, so it's the same when 0.5 frequency, and this is a lot more nearer to 1, the starting point, which is 0.2 something, 0.25, and a lot more nearer to each other when the frequency is 10. So it can be said that as the frequency increase, the noise also will increase and make the result during rainy day more scattered. Okay, that's all from me. Thank you.
Next up, we will be present about the question number 4, which is to compare the performance of the FDMA and of DMA based on the result of them. So that I can say that for any FDMA, its transmit data is a different channel as can be seen in the result. There are 40 channels to display the result. For normal day, the data is clear with very minimal noise, while for the rainy day, the data is bad condition and unclear due to the noise. For FDMA, they transmit all the data by using one channel as can be seen in the result. FDMA is a channel access method used in some multiple access protocol. It's allowed to multiple users to send data through a single communication channel by dividing the bandwidth. FDMA can split the total bandwidth into the multiple channel. For FDMA, the multiple access is achieved by assigning subset of the subcarrier to individual user, which allow the simultaneous low data rate transmission for the several users. So that's all.